Okay, everyone, welcome to MI205. We're winding down the year here. This is one of the last two lectures. This is one of the last two lectures that we have. There's this week and next week. Just a few reminders. This Friday we will post the final exam, and you'll have a week to complete that online. And then also the projects, hopefully everybody's gotten a start or fairly far along on their projects at this point as well, because they'll be due very soon as well. It's listed on the page as to when they're due. So what we're going to cover this week is a chapter that we missed a couple weeks back called Modeling Outside of R. And for this chapter this week, what I hope to get out of this is for you to understand the usage of the Metrum RG package, or at least portions of it, not the entire package, because we've been actually, lots of that package has been used by Tim Bergsma throughout the course as well. Specifically though, we're going to hopefully understand the usage of some functions called metasub and resample. We'll be able to read in and plot the results of a POP-PK analysis using non-mem, and then we'll read in and plot the results of a relatively rudimentary WinBugs analysis. Not so much to demonstrate how to use WinBugs as much as it is to show that there's some functionality there that you can use. And then finally we'll understand the usage of rlog, which is another function in Metrum RG. Okay, so one might ask, why are we doing this? Well, the reason that we even have this chapter is because a lot of times the software applications that we use or the software that we use isn't limited to, say, R. I mean, there's lots of external software that you might use. You might do something in WinBugs, you might do it in non-mem. And then each of those applications that you use requires some degree typically of pre-processing as well as post-processing. And we saw a lot of information on pre-processing in the data assembly sections and then in the advanced data manipulation sections. So what we're going to talk about now is some of the post-processing that you might do from, say, a non-mem run especially, or WinBugs, if you use that in your analysis. What we're not going to cover today is we're not really going to talk about developing models in non-mem or WinBugs, because the scope of that's really outside of this chapter. But it's mainly going to focus on some pre-processing and post-processing steps that can be done in R. And we'll do that through the use of the Metrum RG package. And again, most of you have seen this package at least loaded before, I think, throughout the semester. So a little bit about Metrum RG, just quickly, package. We developed it at Metrum Institute. It's really a suite of tools for lots of things: data set preparation, running non-mem, post-run plots, creating LaTeX tables, kind of a Swiss Army knife, so to speak, of pre and post processing. So today we're really going to concentrate on our couple of functions that are listed on in section 8.3, mainly non-R72, which is the function that actually calls non-mem, runs non-mem, plot-R, which does some of the post-processing plotting, rlog, which summarizes across one or a given set of non-mem runs, and then resample data frame and metasub.character. And these are both functions that are very helpful for, say, taking one control stream and making many, or else taking one data set and resampling it in kind of the typical way we might do it in, say, a non-mem analysis to make many for, say, a bootstrap. And so the first thing we'll take a look at, well, first what we'll do is we'll go ahead and load Metrum RG if we were up on the grid. And what you'll see here is, you'll see the typical messages. Basically, it's going to tell you that Metrum RG 5.1 was loaded. And you'll probably, for those of you who use this already, you'll know that I think there's even newer versions that are out there on CRAN. You can download this from the R CRAN site, but this version is fine for what we are doing today. So let's take a look at the arguments for the non-R72 function. So one of the first things we can appreciate is there's lots of them. This particular function has a whole slew of arguments. We're going to concentrate on just a few here for our purposes. Mainly the run function, command, and I think we'll pass in some categorical and continuous covariates at some point. But this function is basically will allow you to run non-mem. So for example, let's just pull up a quick, so right here up on the screen, let me just put a couple of new lines in here to make this a little easier to interpret. Okay, so what we have here on the screen now is what you would kind of consider to be the minimalist number of arguments that you might need for a non-mem run. Currently the way it's set up here on the Metrum Institute server. You have to specify a project directory, which is the working directory for where your control streams might be located, your non-mem control streams. A command that points to where the installation of non-mem is. And again, this assumes that non-mem was installed with our nmqual installation tool. And then specifically a run number that refers to the control stream, and then this grid equals true is not something to get overly worried about, but basically it indicates that in fact you're running across a grid computer cluster that has more than one compute core. So the first thing that non-R does, just as a little by the way of background, is it does some, I guess you'd almost say, error checking. So the first thing it does is when it starts to run is it checks to see if 1.ctl exists. And I should have said that, but I mean, the run number here that you specify, it accepts as arguments simply a vector of numbers, 1 to whatever number you need to give it. Obviously, control streams are called 1.ctl, 2.ctl, 3.ctl to whatever number you want. So the first thing it does is look to make sure it's there. If that control stream doesn't exist, there's no use in trying to go any further, and you'll get an error message back indicating that that doesn't exist and that you then need to go and figure out why it can't find them. 9 times out of 10, it's because you've specified the wrong project directory here. And just by way of that, if we look over here on the right, our project directory is, like I said, home, Bill K, MI205, modeling out R, and what you'll notice is this directory is full of things like non-mem control streams and a bunch of other files, but mainly you'll see 1.ctl is there. So if I were to go ahead and run this command on RStudio here, basically the main thing you're looking for is this non-R complete. That indicates that at least the initial command was run and there's something going on in the background. And in fact, I know for now that this non-mem run is ongoing. And what will happen is eventually you'll get a message basically saying run 1's complete. And so now what we can do is if run 1's complete, this actually demonstrates the use of plotar, because plotar as a function, and we can take a quick look at that function as well. Plotar takes another long set of arguments, but side effect of running non-R or non-R72 with MetrumRG is that when the run is finished, it goes ahead and calls plotar to do a bunch of diagnostic plots. So the first question is asked here is, can you run non-mem if it was installed without the Metrum installation? The short answer to that is yes. We have built in what I would call hooks or ways to kind of bypass a lot of this code. Specifically, there's a function option called udef, which is user defined, where you could in fact input the path to, say, the NMFE 7.2.bat file, followed by the control stream name and the output file, and it'll go ahead and run that. The difficulty here, the problem with that is that that'll work just fine. What it's going to do though is it's going to bypass all the other features that we have here then built in. So you won't be able to do things like take advantage of multiple cores or anything like that. So it was built in as a hook for people that don't have non-mem installed with nmqual, but if you really want to use MetrumRG and the set of functions to its complete and ultimate use, you'll need to have a non-mem installation with nmqual. Okay, so once we've run non-R and it's finished, tells you it's complete, then tells you that run 1 has been submitted, then it tells you that it's been completed, and what we can do is we can then take a look at, if we look over here on the right panel, we'll notice a file called diagnostic plot review, and it's labeled _1 because that's ControlStream number 1, and if you pull that open, let me just make this just slightly bigger so we can see it. What you see is a standard set of diagnostic plots, things like observed versus predicted, individual predicted, residuals, conditional weighted residuals, and then versus predicted in time, quant QQ plots of residuals, weighted residuals, and conditional weighted residuals. And then it actually, then the last thing it does for you, unless you've asked for additional plotting, things like covariates, it'll just give you basically one of the things that non-mem outputs in the output file is a gradient search. So this will show you how the scaled parameter changed over the course of the non-mem iteration, as well as how the gradient changed over the course of the non-mem iteration. So again, a set of, or a suite really of diagnostic plots that doesn't, it doesn't do everything you need to do with respect to plot reviews, but it gets you pretty far. Okay, so that's kind of in a nutshell how to go about running non-mem, assuming that you have a control stream generated. Now let's talk about oftentimes when we're doing modeling, external programs, and I mean things like non-mem, WinBugs, they require control files. So in the case of non-mem, it's a control stream, and majority of people who are in this class have seen a non-mem control stream, and this is the file that tells non-mem, the kind of model that you want to use, and information about what plots you want. So you can think of it as really the controlling parameters. Oftentimes, what we need to do is we need to tweak this file, whether it be for maybe changing initial estimates, or maybe we want to generate 1,000 new control streams and tweak the initial estimates each time for a different set of runs. Oftentimes there may be 30, 40, 50, or 60 non-mem control strings for a given analysis, and then on top of that, that doesn't even account for things like bootstraps and predictive checks, where you might have, for a bootstrap, you might add 500 or 1,000 more control streams. When you talk about other programs and software like WinBugs, the number of control streams are probably less. But in general, what you're left with really is the unenviable task of having to edit and track changes to a large number of these files. And you can do it. We've done it for years and years just by opening up a file, making changes and saving it as a new name, and that works fine, all fine and well. In fact, some people still want to work that way. Another approach, especially when you're doing things like, let's say that you want to create many control streams from one, and maybe all you want to really change are maybe the initial estimates, or maybe you're doing simulations and you want to change the parameters that are going to be used in the simulation, or you want to change just the data set names because you're running bootstraps. A package that you can use from MetrumRG is called metasub. And metasub is really a generic function with methods really for characters as well as files. So if you were to do something just like question mark metasub, you really wouldn't. Well, actually, you would get the help file over here that indicates the help for metasub, basically, and it tells you what the arguments are. But what we'll do is let's just take a look at args. We'll do args metasub. And I think actually this is where I was talking about here. So if you have to do metasub character, so you have to actually specify that we're going to be working with the character, the input to metasub is going to be a simple ASCII file. So the function takes compared to some of the other functions we've seen, it takes a limited set of arguments. X, that being the file that you're going to work with, names being the output of the files, pattern and replacement, which refer to the pattern that you're searching for as well as a replacement, and these are typically a one-to-one match. So you search for 5 different patterns and you replace it maybe with 5 different patterns, or you could be a one to few. So I'm sorry, like a 3 to 1, maybe where you search for a given pattern and you just delete it out for the replacement, so there is none. Out just represents where you want those files to be written. Suffix is it's exactly what it sounds like. It's the name tacked on to the end of the file. So if you were to say names equal 1, the end of that, the suffix on that would be 1.txt. And then fixed equals true refers to whether or not it accepts regular expressions. And we're not going to talk about how to use regular expressions because it's way outside of the scope of this, but I will give you an example of how you might implement a regular expression pattern search in a call to metasub. So we've already loaded obviously MetroMarG, and if you're obviously you could do question mark metasub, and you can come over here to the right. Let me just make this a little better. You can come over here to the right and it'll tell you exactly the same thing that I just talked about, so you can always get the help file, and I think there's even an example here of working on a ControlStream and doing a pattern and replacement, and I think there's even there may even be and there's not a regular expression argument here, but I'll show you a regular expression example. Okay, so let's take a look here up on the upper panel here now is a call to metasub. So what we're reading here is you're reading a file called 1.ctl. That's the X part of that. And I should really, if I wanted to be conservative in my approach, I would say X equals. That just assures that you're not just assuming the order of the options, so you actually know that that's what you're supplying as the argument to X. As I said, the names is the name of the file that you want to create. So my file that I create from 1.ctl is going to be called 100.ctl. So what am I going to be looking for? Well, I'm going to be looking for, first of all, the name of the data set. That's one item. And the second item is the beginning of the line that starts $table ID. So it's going to be looking for that verbatim in the data set, in the control stream. What's it going to replace? Well, it's going to do a one-to-one replacement there. So ex1r.csv is going to replace with the name 1.csv. And all I'm doing in this case is I'm just commenting out. I'm just adding a semicolon, and that's just it's a comment character for a non-mem control stream. And now where am I going to write it? Well, I'm going to write it to the existing working directory, which is a dot, and the suffix is going to be .ctl. So let's just take a quick look at that 1.ctl file first so we can see what we're talking about here. And you'll also notice that here on the right panel there is no 100.ctl, so I have no tricks up my sleeve, so I'm going to have to generate and create that file with metasub. So if we look at 1.ctl, the first thing we'll notice is in the data record there's the argument that we're going to be searching for, and down here on the bottom there's a argument for $table that we're going to be looking to comment out. So let's go ahead and run this. Okay, so actually it said that it can't find 1.ctl. So the first thing I think about is, well, what's my working directory set as? So first thing I can see is that my working directory is not right. My working directory in this case is home bill K, but where I think it's supposed to be reading is home bill K, MI205 modeling out R. So I'm going to go ahead and set my working directory here. So I'm in my home directory. I'm going to say MI205 modeling out of R and choose that. So now my home directory should be set properly, and I can do get working directory, and now we'll see that it's the right place. Now we'll rerun this metasub call, and we got no error messages, nothing like that. And let's go over here to the right side, and if we refresh this, What we now see is a 100.ctl, and we can open it and confirm that in fact the name of the data set was changed. And what it should have done is commented out the $sign table. Didn't do that. Should have done that. So let's see if you know what I'll do, I'll check this after we learn class today rather than trying to figure out why. But what I was hoping for actually was to get a semicolon put in each of these places here so I can comment out this table record. I have to go back and see why that did not work. Nonetheless, the idea here really is that what we're trying to do here then is just generate a new control stream from one that already exists. So that would create one control stream, say take number 1.ctl and make another one that's called 100.ctl. Probably what's more realistic, what we would do, is take one data stream and one control stream, I should say, and make a bunch of other control streams. So maybe we would fit, the current data set to a number of control streams, so maybe 100 or 1,000. And so in this case, what we'll do is, in this call to metasub, what we'll do is we'll take again as input 1.ctl and we'll create 10 new control streams, 100 to 110. And now in this case, let's go back up here once. In this case, what I'm going to do is show you the use of a regular expression here. So now what I'm doing here is I'm giving it a pattern, and this double backslash $sign represents a regular expression. So it's basically going to look for the line that starts in $sign data and delete everything else that goes up to but not including the next $sign. And it's going to do the same thing with table. It's going to look for the line to start with $sign table and delete everything up to and including the next $sign. Up to but not including the next $sign. And it's going to replace it with the set of, with two items. It's going to replace it with the number of the control stream, so 100 to 110.csv. So I'm taking advantage of the fact that 100 to 110 are what's inside the code in metasub specified as name. So it's going to say, okay, make the name numeric. So the first time through, name is going to be 100, and it's going to replace the $sign data up here with 100.csv. And it's going to replace everything that's $sign table with semicolon $sign table ID. The out directory is still going to be the same. This time we're saying fixed equals false because we're going to be using regular expressions. So let's go ahead and run this particular control stream metasub call. And if we do that over here on the right now, let me just refresh this so we can see that, in fact, we now have 100 to 110. And let's just take a look at 100 again. So now you'll notice before this $sign data record said 100.csv, now it says 100. Okay. I can figure out why it's not doing the substitution here. Actually, that's a good point. So one thing I'm sorry, I digressed for a moment and was trying to figure out why it didn't do the right table substitution. I figured that out now. So let's take a quick look and I'll explain why. So in 1.ctl, one of the things that I said we're going to do is we're going to look for, in this case, a regular expression that starts out $sign table ID. Well, actually, in 1.ctl, it doesn't go $sign table ID. It actually goes $sign table no print. So if I were to change this argument to that. So it's not specifically searching for ID, and it's looking simply for what for $ table followed by anything until the next $. So let's go ahead and rerun this. In fact, I'll go ahead and let's delete these files that already exist here because they're all wrong. Now, if I rerun this meta sub argument, no error messages, that's good. And let's come back over here and refresh it and take a look at 100.ctl. Again, we'll see that 100.csv was replaced. And if we go now down to the bottom, what we see is that for each place where there was a $ table record, it replaced it with a semicolon and table.id. Obviously, table.id is pretty much useless. The key here really is that I wanted to comment out the table record. And this might be something you might do if you were going to run, say, bootstrap a model, because you don't really need to capture individual table records. You're interested in just the population parameter estimates. So if I were to look at 101.ctl, again, what I see now here is instead of 100.csv, the name of the data set is 101.csv, and it did the same substitution down here. So actually, we figured out why the initial call to metasub didn't work. It's basically because I was being too exclusive on what it was searching for. So it was actually searching for $ table space ID, and it wasn't replacing it with the right thing. Okay, so that's how we might do a one-to-many, say one control stream to many. Maybe in the case of bootstrap analysis, something like that. Other control streams also take ASCII text. So for example, other controlling files are also ASCII text. For example, WinBugs, hierarchical Bayes modeling, the control for WinBugs, say what controls a WinBugs run, or the model file. Again, simply here, I have it up on the screen. Again, I'm not going to talk about what's going on here, but suffice to say that it's simple ASCII text. You know, it's nothing, no binaries, nothing like that. It's simply information that can be edited. So we can take advantage of the fact that it's simple ASCII text. Let me just close out some of these files to get them out of the way. So let's just say that in our let me open up that linear.txt again. Let's just say that I wanted to change something here. I want to change, say, this particular line from this file to something else. Maybe I want, instead of make it normal distribution, mean, and variance, I want to change it to a uniform distribution. Okay, so what I can do actually is I can write a control stream argument. I've actually, not only am I going to change it to a normal distribution, I'm going to add another, these are a list of priors, I'm going to add another variable in there. So here's my call to metasub. I'm going to be reading in the file called linear.txt that we just looked at. The name I'm going to call it on the output side is linear1. Suffix is still going to be text. I'm going to be writing it to my current working directory. The pattern I'm going to be looking for, I'm going to be looking for verbatim this particular line, so x brackets I, and I'm also going to be looking for a tilde d norm 0, 0,001, and I'm going to be replacing that with the following, x comma I plus a power, and then d uniform, and then another variable c. This \n is simply a new line representation, so it'll basically wrap that c onto the next line. So if I were to go ahead and run this metasub call, and let's refresh this side. what I now see here is we can see that we've now added this new variable, C tilde D norm. We've changed A to a uniform distribution. And up here in the Y mean line where I had XI, I've actually added this plus power C comma 2. Again, not so critical to know what's going on here as to know how you might want to do it. What this really does then is this gives you a way within, say, an overarching controlling R script. So what you can envision is that when you're doing an analysis, you could maybe be working in non-mem for a while, and you can have a set of non-R calls that run non-mem, and then that maybe that's followed by a couple of meta subcalls to generate a couple of new control streams or generate control streams for a bootstrap, and then you do that bootstrap analysis. Again, just a bunch of non-mem runs using a non-R call. And then maybe you're shifting over to do some other kind of analysis that involves WinBugs. Maybe it's a dropout model, something like that, time to event. And so this allows you basically staying within R, and this will allow you to make changes to your model file. Now, it may be a bit more, in some cases it might be easier to simply go and open up the file and make a change to it. But I would argue that especially in cases where you're going to take one control stream and write it out to many others, whether it be for simulation purposes or for bootstrapping purposes, something like that, it's much easier to do it programmatically than to go in one at a time and make those changes. Moving from one control stream to the next, say when you're just tweaking the model a little bit, sometimes it's more trouble than it's worth to maybe write some of these expressions to do these replacements. But when you're doing larger scale changes, it's probably better to have it captured programmatically, and then the next time that analysis has to be run or somebody else can check it, they can just check your code. Okay, so now we've seen the situation where we've been able to take a set of controller files, say ControlStream or WinBugs files, and then generate new ones or generate many from one. The other thing that, in addition to tweaking those controller files or those control streams or WinBugs model files, you might want to tweak the data set. And oftentimes in a bootstrap analysis, in addition to, say, generating 1,000 control streams, you have to do maybe some resampling on the data set. And so you want to maybe generate a new set of 500 or 1,000 data sets, bootstrap data sets that are resampled with replacement, some kind of permutation based upon some stratification of the data set. So there's a function written in MI205, and we can take a look at the arguments for it called resample.dataframe. The actual function's called resample, but there's methods for data frames. And if we look at this, let's make this a little bit bigger so we can see it easier. Move it up here anyway, make it really bigger. If we look at this now, what we see is here function takes a couple of arguments. X, which is the data frame in question. Names, which is what we want to call the output data frames. And you'll notice right away that we have an extension that it's going to take. So something like it's going to output a CSV file. It's going to look for a key, and the key is something that you want to resample on. So maybe you want to do resampling with replacement based upon ID. That's typically what we want to do when we're doing, say, creating bootstrap data sets. And by that I mean we're going to say take the existing data frame and we're going to say, okay, I want to generate new data sets that have the same number of subjects. So maybe your original data has 100. And your new data set will have 100, but I want to resample with replacement based upon ID. So that means that, imagine if you have all 100 people in a hat and you pulled out one and put it into the new data set, and then you put that person back in again, shake the hat up and pull out another one, and you keep this process up 100 times. You do this until you have 100 subjects in your new data set. So what that means is that you pull one at a time, and you have equal chance of re-pulling that subject again. So your resampled data set will have the same number of subjects, but it may have one subject repeated more than one time. Again, all of these are outlined in the help file, but just quickly to go through them. Rekey simply says when I regenerate this data set, do I want to rekey? So in other words, do I want to assign new IDs? And of course you want to do that because just by chance you pull the same ID twice. If you say use ID 1 followed by ID 1 again within non-mem, it'll cause you problems. Out is basically where you're going to write those files. Stratify is an important argument, and we'll show an example of that next. But that maybe you want to do some kind of stratification. Maybe in your original data set you have 30% pediatric subjects, say under 17, and the rest of them are adults, and you want to maintain that 30 to 70% distribution in your resample data set, so you could stratify on some variable. Row names are whether or not it writes out row names, and of course we usually don't want those because they're not useful. And then quote is obviously, some of these are very familiar because what you end up doing here is you're writing out a comma delimited file. So a lot of these arguments are the same arguments that you would see in write.csv. And then replace just says, are you doing resampling with replacement? And usually that's what we want to do. So for our particular purposes, how we're going to demonstrate this is we're going to go back to our good old friend prob1. And let's go ahead and read prob1 in. And I did a quick head of this. And so what we're interested in doing is now we're going to resample based upon ID. And if we want, we can, let's just see how many unique individuals we have. Length, unique. So we have 40 individuals. And so let's say that we want to generate 20 new data sets and we want to resample on ID. So we want to use ID as the sampling unit, and we want to stratify based upon weight and sex. And let's say that let's just take a look and see what the summary of weight is. So here we have a weight median of 58, max of 96, minimum of 34. And let's say we want to stratify. Say we want to stratify based upon weight greater than 60 and sex. And if you'll notice here, we have a variable called sex. And if we were going to do unique, I spelled it right. We have two categories of sex. Well, at least that's right. 0 and 1. And so now what we're going to do is what's going to happen through this call to resample. And let me just pull the call up here so we can talk through it a little bit. Sorry about that. So if we take a look up here at this call, what we have is the input we're giving it is prob1, so that's our data frame. We're going to key it on ID. We're going to rekey it because what we want to do is we want to generate, we want to give them, in the new data sets, we're going to give unique IDs. The names for the new data sets are going to be 1 to 20. And by default, it's going to write out a CSV file, so I don't have to specify an extension. It's going to write them to the current working directory, though you could specify some other directory if you wanted. Maybe you want to write them out to a data directory, something like that. And then it's going to stratify. So now what it's going to do is it's going to stratify based upon these factors. It's going to say for weight greater than 60 and prob1 sex. So what that means is that each of our new data sets, they're all going to have 40 individuals, and generally they're going to have, if you were to say, how many people do I have greater than or less than 60 of each sex? It's going to have the same number of individuals in your new data set as you have in the old data set in each of those categories. But people could be reported more than once, could be replaced more than once. So, where might this come into play? Well, maybe weight greater than 60 represents some covariate range of interest. Maybe people greater than a weight of 60 have some different covariate effect, and you want to make sure, or maybe there's very few people with a weight greater than 60, but they're relevant to the model. And you want to make sure that your resample data sets at least carry some information on that. In this case, you want to stratify. You obviously don't, just a little bit about stratification when you're doing this. You obviously don't want to over stratify. I mean, you don't want to start cutting these new data sets up to the point where you end up getting back your same data set again. Highly unlikely, but you can get back fairly close to it if you give it enough of stratification variables. You can eventually stratify to the point where you get almost the same data set back that you started with the exception of the fact that it's resampling with replacement. One other thing to keep in mind, because I guarantee you this will occur, the items in Stratify cannot be nested within one another. So this isn't really feasible here for sex, because really you don't have, and not for weight either, because weight is one weight for everybody. But imagine if you had a stratification variable was formulation, and you had a situation where people were in a crossover study, so they received formulation A and B. If you tried to specify formulation as a stratify variable here, you would get an error message back from resample, because basically it's going to say, okay, within my unique key, so within each ID, is there a unique level of stratification? If that's not true, resample is going to give you an error message, because it's not going to let you split up a subject. So it's not going to let you take part of only half of a subject. It's going to take a whole subject at a time. Just something to keep in the back of your mind, because I guarantee you that this is a very common error that you end up with. Okay, so if we look over to the right, we'll notice that there's no data frames called 1 to 20.csv. They don't exist. And so I'll go ahead and run this resample piece. And if we refresh this, what we'll now see is we have a bunch of new data sets. There's 10, there's 11, there's 12, 13. And just because of the way RStudio does its filtering and sorting, I guarantee you they're all here. We can read one of these in, just if we want to just make sure that, well, let's just read one of these in real quick, and we can verify that in fact it has the right number of subjects. So if I were to do read.csv, let's read this into a test, because I don't want to. And I'm going to read in, let's just read in 2.csv. And I almost guarantee you I'll get this code wrong initially, but we'll, let's see if I got this right. Okay, we can, and I actually did read in, I did get the right code. So let's do a length unique test $ID, and we'll see we have 40. So again, we have 40 individuals, but I guarantee if you tried to compare, say, ID1 to ID1 in prob1, it's not necessarily going to be the same one. In fact, if we do a head of prob1, actually, we can see very quickly, let me just make this a little bit bigger so you can see. We can actually see that in prob1, ID number 1 is not equal to the ID1 in test. And it shouldn't be, because we're doing resampling here. So they shouldn't necessarily be the same subject. So now what we have is we have 20 new data sets. And these data sets would probably be, this approach, this idea of generating multiple data sets would be combined with the idea of generating multiple control streams in, say, a bootstrap analysis where you want to end up with getting precision on your model parameters. Okay. Okay, so let's talk a little bit about then reading and plotting non-mem output. So we talked a little bit about, or I showed you how we might run a non-R call to generate non-mem output, to run non-mem, and then the plotter call. And I showed you the minimalist really approach to non-R72. And by that I mean I showed you the argument that takes the least amount of information really to run, or the minimum items to run. So now probably a more likely call to non-R to do a model run would be what we see up here on the screen now, where we specified again the same project and the same command. Now we have a new run, which is 4. And now what we've started to specify are some other optional arguments and these are really for the plotting side, not for running non-mem. this is basically going to be used after the run is complete to do some plotting. So while we're talking about this, let me just go ahead and submit this run. So I've submitted it, and so what this is going to do is it's going to actually, it's assuming, one, it's going to read things that are like this cont cove and cat cove refer to continuous and categorical covariates. It's going to read those from your data set. So it'll pull the information for these covariates from your data set. It's going to pull the ADA list and the PAR list. These are your parameters or your ADA variables from the non-mem run from your non-mem table step. So there has to be a table file that was generated that contained these. So it's going to pull these from the output of the non-mem run. I'm also passing into it a grouping variable. So what it's going to do is the diagnostic plots that make sense, things like the individual versus predicted and the weighted residual plots, it'll generate those twice. Once for sex equals 0, once for sex equals 1. This grouping variable could be, doesn't have to be limited to 2 categories. You could imagine maybe you wanted to group this by, say, creatinine clearance group. Not necessarily creatinine clearance, but maybe mild, moderate, normal, mild, moderate, severe renal function. So you could have a grouping variable based upon renal function to make sure that you're adequately fitting each of those groups. And then I'm also taking advantage of the fact that if you want, you can pass in a argument for plotting such that the DV name or the name on the X and Y axes in places where it would be appropriate, it substitutes this piece in. So now instead of seeing predicted or observed, it'll say test nanogram per ml, observed, predicted test nanogram per ml. So this run completed. Now if we look over here in our right panel, we're going to have a new file down here. And now what it's done is, because I've added a grouping variable, it's tagged on that information to the name of the diagnostic plot. So now instead of saying diagnostic plot review underscore control stream name, it actually adds on the grouping variable. So I know that this is my diagnostic plot for the 4th control stream, and it's grouped by sex for those plots that would be relevant to look at that way. So if we take a look here now, what we'll notice, we have population and individual predicted, and now it's saying basically for 0 data, and 0 means the grouping variable is 0, and it's 0 or 1, and so it'll go through all the plots for the 0 category, then it'll redo all those plots for the 1 category, and then it'll do the plots that are most appropriate. And as I'd said, we supplied it a name, and so probably you wouldn't supply it test nanograms per ml. Maybe you'll say observed amoxicillin nanograms per ml, or whatever particular drug that you're working with. Now we're going to start to see something new. So now that we've asked it, now that we've supplied some covariate names and parameters, it's going to start generating some other things. So the first thing it's going to generate is a scatter plot of covariates. So it's just going to take all of your continuous covariates and generate a scatter plot matrix. So it's going to plot one against the other and run a low S smooth for it. So you can look and see if there's highly correlated covariates. And obviously in this case, since weight is a part of the creatinine clearance equation, weight and creatinine clearance are correlated, and you can see that from the upper and lower, upper left and lower right corners here. And obviously age, not so correlated with creatinine clearance or with weight. You can counter this in the situation where you might be dealing with pediatric patients, where you might very well see a very strong correlation, between age and weight. The next thing it does then, it starts graphing continuous covariates versus categorical covariates. So for each of the categorical covariates, in this case we only have sex, it's going to plot box and whisker plots for the continuous covariate by the categories of the categorical. So now we have, for males and females, it's plotting weight, age, and creatinine clearance. And I believe in this data set, males were 0 and females are 1, so this isn't highly unusual that you would see, a higher weight in generally males and females. Ages are evenly dispersed in the data set, so we don't see much of a difference there. Don't know why we're seeing a difference in creatinine clearance, but quite frankly, they're all relatively normal, though the females look to be somewhat lower, really, in creatinine clearance. Next thing it's going to do is generate a scatter plot matrix of your eta estimates, so of your random variability estimates. And so here you might be looking for things like correlations in these plots to maybe work into it off diagonal elements of your model. And then it's going to do the same thing for your parameters, your individual parameters. And now it's going to start generating some other diagnostics. So for any of the etas that you specified, it'll plot histograms, and then it'll also plot distributions. And sometimes this density plot, they're both distributions, is sometimes more helpful. And what you're looking for here really is you want to look for things that are not normal, maybe bimodal, things like that. I'm not going to go into all the diagnostics. And then it's going to start plotting some eta diagnostics, some things you might look at in addition to others for maybe looking at covariates. So in this case, it's going to say for categoricals, it's going to plot continuous categorical covariates, and it's going to plot the box and whisker plots of the eta estimates by each category. And for continuous covariates, it's going to plot them for each particular covariate, and then it's going to run a low S smooth. And again, this might be some place among others where you might look towards to maybe help to see if there's some relationships you need to build in. Here's quite an obvious one here for creatinine clearance that you might want to have to build something into your model to account for clearance is your eta variable, to account for the relationship between creatinine clearance and clearance. It's going to do that for all of your etas and all of your continuous covariates. It's also then going to go ahead and plot continuous rated residuals versus categorical and continuous covariates. And it's going to do that same plot for parameters and gradients. So again, it's going to give you a whole additional sets of diagnostic plots then that you can look at to help start guiding maybe some parts of your covariate model. One thing that you're not really limited in, you can actually run this. You can run plot-R. This actually runs plot-R, that function, after non-R is run. You can also run it as a standalone argument once you've run your non-mem run and you have your table files. Like for instance here, like we have 4.tab and 4par.tab. We could run plot-R directly and generate these plots post hoc, so generate them after we've generated the non-mem run. One other example here that we'll probably finish up on today, and then we'll finish up the last parts of this chapter on Friday, are, let's say that in addition to our, as you can see, it does quite a bit of standard diagnostic plots, but you could envision that there might be other plots that you want to plot as well. So in addition to this, what you can also do is you can pass in an R script via this hook, again, that we call Epilogue. And I call it Epilogue because it's run at the end of a non-mem run. So when a run is finished, whatever script you pass here in Epilogue is executed against the output of the non-mem run. So let's just go ahead and run this model again. So what it's going to do this time, it's going to go ahead and generate the same set of plots. In addition, it's going to execute this epilogue ex.r. There's nothing unique about this name. I just called it that so that we could, so that it indicates what's being done here. And actually, this will be very helpful if you want to use it to write some of your own scripts. And I have it highly commented, so it tells you what is available in the global environment for this script. In this case, the script is going to do, there's a lot of code here, but really what it's going to end up doing is it's just going to end up generating two additional plots. Time versus DV, so it's going to generate time versus the observed, and then it's going to generate a histogram of eta 1, something it already generates. It wasn't so much designed to be anything novel, but just show you how you might, how you might incorporate an additional script in here to do some plot, to do some post-processing. Now, one thing that you're not tied down to it just being plotting. You can do anything. This script could do anything. It could run a set of statistical tests. It could do some kind of data summarizing on the output file. It just so happens to be doing plotting here. So what is my output now in this case? Well, my output, I still get my diagnostic review plot here, and I also get, let's see, what else do I get here? Here, bear with me a moment. I want to open up this file so I can see what it is I was calling that file. This executes this script, and it should give me a file called testplots4.pdf, and for whatever reason it did not do that. So once again, I found a problem. So I will figure out why it did not do that, and I will get you back that corrected code for Friday's class. However, what should have occurred is that when this run finished, it went ahead and ran this particular script and output a file called test4.pdf that contains these plots. I'll figure out why it didn't do that for Friday's class. Okay, so what we've covered quite a bit today, really about how to use non-R, how to do some pre and post plotting, how to do some pre-processing of control streams. And then on Friday, what we'll do is we're going to finish up with just a little bit about plotting some output from WinBugs, and then how to use RLog to summarize a set of non-mem runs. And let's just take a quick look at the homework, because you can go ahead and do this. This particular set of homework doesn't require anything I'm going to cover on Friday, so I'd like you to try to get started if you can. So what I'm asking you to do is use the metasub function to generate 10 new control streams, and then maybe how would you change that to generate 200, or maybe to do it for starting at 200 but only do even numbers. You do a resample run to resample prob 1. Also then do the same thing again, but do it in just 2 function calls, one to resample and one to lapply. That's just to test some of your learning from previous weeks. And then finally, this is not something you need to share, but I may ask it out for input, and that is read in the output and generate 3 to 4 diagnostic plots for any modeling performed outside of R. You don't have to share this with the class. In fact, it's probably too much, but I'd just like to know if anybody had any problems in doing this. Not problems from a perspective of not knowing how to use R, but did you run into any problems in processing the data, bringing it in, and then what types of plots you might create. So I may actually ask for some examples of the plots you created in Friday's class. So again, Friday we'll just cover up those last 2 items, and I'll also give you see why that epilogue.r didn't work. I thought I had tested that, but for whatever reason, even the best laid plans go astray. Hopefully, like I said, if you have any questions about the project, you can ask them. If you have to, you can post questions to the forum, because more than likely, if it's a question you have, it's a question that somebody else had as well. If it's something that you think is sensitive to your answer, you can email it directly to one of us, and we'll choose either to answer it if we can, or if it's something really inherent to the problem itself, we may not be able to answer it. So it's not a problem. Anyway, okay, everybody, that's it for today. and we'll see everybody back in Friday to cover the end of this. And just a reminder, again, Friday, probably sometime before the end of the day, we'll open up the final exam, and you'll do it just as you did the midterm. You'll take it online, you can print it out, work through the problems, and then enter the actual answers once you have the problems worked out. And again, hopefully you're working on your project and you're getting pretty close to completing that. So again, post any questions on that to the forum, and I'll see you all on Friday. Thanks, everybody. Good question. Somebody asked, how long do we have access to the website once the course is over? I don't think that we're really, I'm not sure. Let me check and see. I mean, it may go on for a little while, but I don't think it's going to be for any great length of time once the course is done. Let me check into that, and I'll let everybody know on Friday, answer it knowing how long you'll actually have access to that website once the course is done. If there's anything that you want to actually grab from it, I would say grab it as you go along. If there's any kind of work you've done that you want to save, make sure you do that so you don't lose it. But we'll give you plenty of notice before we say turn off your access to that site, and I'll check on that for Friday's class. Thanks, everyone.